In this video we're asking, do you actually need to test the cable feeding this light fitting if it's coming from a wiring control module? Because we test the fixed wiring to the modules, like these ones from Flex 7, but what about the wiring that feeds the luminaires? You might have 10 fittings all running off one single plug-in lead. So do all of those need testing as well? And if they are plugged in, should they be treated like a portable appliance? It might sound like a small detail, but it could change the way that you test and certify a whole circuit. If you haven't come across them before, LCMs, or lighting control modules, are basically the hub of a modern lighting circuit. They normally sit above ceilings and let you plug in multiple luminaires, control units and sensors all from one central point. And they're a massive time saver on site. Instead of hardwiring every single light fitting, you can just plug each one into the module with these pre-made leads. And it's this modularity that makes installation quick and tidy. And this is why you find systems like Flex 7 in most commercial installs. Offices, hospitals, airports and schools. You'll find these systems everywhere you have a lot of repeated lighting layouts. And if the system includes DALI control, that's where it can get really clever. Each fitting can be addressed digitally over the two core control line. That means you can dim, group or reconfigure lighting all through software without ever having to rewire the circuit. So they're efficient, flexible and built for quick commissioning. But that plug-in convenience raises a really interesting question around testing. How far does your verification have to go? The LCM, or in this case the Flex 7 module, is usually supplied on its own individual circuit. In a large office, several modules might be fed from the same breaker, each serving a section of the ceiling grid. And as a new circuit, it needs to be tested. Every point on that circuit needs to be verified before it's energized. And that means the full suite of tests required under an electrical installation certificate, or EIC. And that is your continuity of conductors, polarity, insulation resistance at 500 volts, then once it goes live, earth fault loop impedance and RCD operation, and you would usually test up to the last fixed point, in this case the lighting control module. And if the readings check out, this is when you'll start plugging in all of your light fittings. And then it hits you. Do we test the luminaires separately? Do we include them in the same test? Or do we just leave them untested? Now, when I was an apprentice, I remember sitting in a cold plant room wiring flexes into 600 by 600 luminaires to go into the ceiling grid. Hundreds of them. And no one ever asked who tested them once they were connected. But now the lighting is plugged in and the system is live, where do we go from there? On site, the advice varies. Some say the luminaires count as portable appliances. Others say you just test to the lighting control module and that's it, you're covered. And others say, why bother? But that doesn't really settle it. Because in reality, these systems blur the line between fixed wiring and factory-built equipment. The lighting control module is pre-tested, but once you start plugging in light fittings, then you've created a new circuit assembly. The final wiring from the lighting control module to the fitting forms part of the electrical installation that we are responsible for, and that is where testing can become more complicated. If you try and take an R1, R2 or ZS reading through one of these Flex 7 units, you may hit a bit of a wall. The electronics inside, especially on these DALI systems, may break that direct line path, causing readings to fluctuate or maybe even drop out completely. That's why some testers may make up their own breakout lead so they can access those connections safely. The problem there is that approach only confirms the fixed wiring. It tells you nothing about continuity or polarity beyond the lighting control module. And at the same time, you can't just fire 500 volts through it for an insulation resistance test. You could damage sensors and control gear instantly. You need to isolate the electronics section or test it at 250 volts DC if the electronic control is connected. So we end up with a gap. This is where you should prove that everything downstream of the lighting control module is safe and connected correctly. The good news, you don't need to repeat every single test from scratch. You're not recertifying the fixed wiring. You're verifying the wiring from the lighting control module to the fittings. And there's a number of ways in which we can do this. But before I get to that, don't forget to send me your electrical questions and queries to willittrip@efix.co.uk and I will scour the internet for your answer so you don't have to. So let's start with continuity of protective conductors. Disconnect the CPC at the board or disconnect it from the lighting control module so you're not looping through the upstream circuit. Then use a wander lead to test from the lighting control module to each luminaire or fitting. If you've got multiple fittings wired off one plug, then go to the furthest fitting. You're confirming that the earth path extends to every single fitting and that any exposed conductive parts will disconnect in the event of a fault. Typical readings on modular wiring should be low, between 0.05 ohms and 0.2 ohms, depending on the cable length and size. Anything higher or an open circuit may mean a damaged cable or a loose connection. Next, check polarity. Most modular systems use keyed connections, but it's still worth checking that every lead and splitter is wired as intended. For insulation resistance, you need to be careful. The lighting control module and the fitting will contain sensitive electronic control gear, sensors, DALI interfaces, dimming circuits and drivers, none of which will appreciate 500 volts DC smashing through it. So isolate or disconnect the electronic control gear before testing. Where that's not possible, use 250 volts DC as permitted under regulation 643.3.3 of BS 7671, which says, where connected equipment is likely to influence the measurements or results of the test or be damaged, the test shall be applied prior to the connection of such equipment in accordance with table 64. Following connection of the equipment, a test at 250 volts DC shall be applied between live conductors and the protective conductor to the earthing arrangement. The insulation resistance shall have a value of at least 1 megohms. Finally, perform a functional test. Re-energize the circuit and confirm that each luminaire operates as it should through its control system. And this is your proof that the system is working as it should. At this stage, you've confirmed the integrity of the complete lighting circuit, from the distribution board to the lighting control module to every single luminaire that it serves. You haven't bypassed any electronic components, you've not stressed any equipment, and you've verified the full safety chain. Well, maybe the light fitting should be treated like a PAT test, or more accurately, an in-service inspection and test of electrical equipment. Do we test each fitting while it's on the ground before it goes into the ceiling grid like it was a Class 1 appliance? You could. In fact, you could make up an adapter that plugs directly into your PAT tester, just like this one that I've done to plug into my Mega. Let's think it through. A Class 1 appliance test starts with a visual inspection. You check the casing, flex, plug for any damage or loose connections. On a new luminaire, that's pretty straightforward. Look for crushed cables, damaged connectors, or stripped insulation around the entry point. Next, you carry out your earth continuity test. The PAT tester sends a small DC current down the CPC to confirm resistance between the earth pin on the plug and any exposed metal, and you should get a reading below 0.1 ohms on a short lead. That proves that the protective conductor is sound and the fitting is properly earthed. Then comes insulation resistance. The tester applies 500 volts DC or 250 volts DC if it is a sensitive piece of equipment, and does that between live parts to earth to confirm that there's no breakdown in insulation. Again, for a new fitting, you would expect a reading lower than 1 megohm. Most will be much higher. Finally, some testers run a functional test, powering the fitting to make sure that it operates correctly. That's useful to confirm polarity and check that no components have been damaged before installation. So technically, yes, you could treat each luminaire as a Class 1 fitting before it goes into the installation. You get the reassurance that each fitting is electronically sound and correctly earthed before it plugs into the lighting control module. But once we plug it back into the lighting control module, it then falls under the fixed installation, and the testing responsibility moves back to BS 7671 rather than the in-service inspection and testing of electrical equipment. So where does this leave us? Regulation 643.2 of BS 7671 says that every circuit must be verified after installation. That means the whole circuit. And when speed on site is critical, modular wiring systems like this one from Flex 7 make a big difference. They save time, reduce wiring errors, and make everything consistent. But that doesn't change the responsibility to verify every point. Whether you test the fittings in situ, on the ground before installation, or even treat them like a Class 1 portable appliance, the key thing is that they've been tested and documented. Because at the end of the day, it's our name on the certificate. So, will you test them on site? Will you test them on the ground? Will you PAT test them before they go up? As long as they've been tested and verified, you're all good. But what do you think? How do you handle testing on modular wiring and lighting systems? Be sure to let me know in the comments. And if you want to find out more about how DALI lighting systems work, then click the video on screen now.